Hey everyone, it's me Kaizo, and in this video I'm going to show you how you can clone audio directly through Python without opening the GPT SoVITS web UI. So let's get real. The GPT SoVITS web UI is great for testing, but if you're a developer or content creator, this can really be a bottleneck. So today I'm going to show you how you can break free from this browser and take this directly to Python scripts so you can incorporate this in your projects. So with that, let's get started. So why is scripting better than just using the web UI? Because first case, speed. So if you're using a browser to use it, there's a browser overhead which can essentially just decrease your performance of generating the audio inferences. So it's better to just use it from scripts, which is just load the model once into a VRAM and it will generate the other voice inferences instantly. Second part, integration. You can, if you are using it to Python scripts, you can integrate into any of your projects you're making, like any Discord or any local AI agents or any projects you're working on. It's generally easy to integrate if you are using through scripts. So with that, now let's move on to coding. Okay, so we are going to be using Python for making this. So make sure you have Python installed on your system and the GPT SoVITS setup. You can set up GPT SoVITS by watching my previous video. Just make sure you have like you have installed the requirements.txt. I'm still going to show how you can make sure to use a virtual environment. So we are separating our global environment with here like separately. So use a virtual environment is recommended. So just install the library. First go to the GPT SoVITS folder, GPT SoVITS, and just install requirements.txt. Just hit enter. It will install all the modules. I've already installed, so it's saying requirement already satisfied. But after installing the module, just check if like the pip show torch and torch audio. These two needs to be of same versions, because like in some situations I saw that in this requirements.txt they haven't mentioned like the version for torch audio, and this downloads the latest version, which in some cases are not supported because the tested environments they have used for this PyTorch or have specific PyTorch requirements. So make sure you're using that version of the PyTorch that is mentioned here, and when that matches with the Python version, make sure you're Python 3.11, because like the PyTorch only works in 3.11. So you just need to check if these two modules are of same version. So just enter pip show torch and torch audio 2.7.0 plus CU128. So this is the CUDA version. So if you have an NVIDIA graphics card, you can use CUDA also to make your like inference process much faster. If you don't have a CUDA, you can just use normal torch. I'm going to show you how you can install like with CUDA version. So just use pip install torch equal the version we are going to be using is 2.7.0, and then give a space with torch audio equal 2.7.0, and after that just paste this link, which is we are providing the index URL like to direct to PyTorch and installing CUDA 128 version of it. Just use it and just enter. It will download it. I've already downloaded it, so it's saying already downloaded. So with that, let's now begin. So first, make a new Python file. I'm going to name it main.py, and in here first we're going to be importing OS. So after importing OS, we are going to use the OS to change the directory to GPT SoVITS so we can access the files from here. So I'm just going to do os.chdr, which is change directory, to GPT SoVITS. So in string, make sure you have the name right. After that, actually get these two modules. So pip install python.env. So we are going to be storing the model parts and our reference audio parts in a .env file, just to make our like project much more cleaner, so we don't have like a bunch of parts lying around in our code. So to our .env and sound file. So sound file is going to help us in like creating the .wav file after we get the audio from the GPT SoVITS. So I press enter. So after the modules are installed, let's go ahead. So first import sound file as sf, and then we are going to be importing from .env import load.env. This is going to help us in loading the environment variable. So after that, now we are going to be importing the functions that we are going to be used for creating the audio. From GPT_SoVITS.inference web UI, we're going to be importing change GPT weights. So this is for adding the GPT model, and this is for the SoVITS model. And after that, get this one also, get underscore TTS.wave. This is going to help us in generating. So first we're going to be loading the GPT model, which our like the text is going to pass on to the GPT model, which it's going to like create a semantic map. After that, it will go to the SoVITS model, which is going to prepare the audio, and get TTS wave is going to return in a waveform. So after that, we can move ahead. So now we need to get our model parts. So in GPT SoVITS, go to GPT_SoVITS, and here go to pre-trained models, and here just get the model you need. So in this case, I'm going to be using V3 models. You can use any other models like GSV V2 Final or V4 or V2 Pro, any model you can use. First, I'm going to be getting the GPT model and then get a SoVIT model. So S2G v3 for the SoVIT model and S1v3 for the GPT model. So after that, getting those parts, create a new .env file. We are going to be storing all our parts in a .env. So in here, first make a GPT SoVIT variable, and in this just store the path. Make sure your path has these things, double backslashes, because in Python, if a single backslash is there, it considers that as an escape sequence, and in some cases it might lead to like the path being like a corrupted path, so it might not work. So use double backslashes for a proper path. After adding the path, just add the other ones also. After adding all the parts for the reference audio and reference text also, you need to have like the different reference text and reference audio also here, because it's going to be using that. So after adding the both all the 4 parts, GPT model, SoVIT model, the audio part and the reference text part, we can move ahead. So in here, now let's get those parts. Make sure you have this load.env for loading the environment variable first. So first, let's get GPT model. So GPT model equal to, we are going to be using the os.getEnv to get that environment variable. Get env. After using the get env, get the variable name you use. So I'm going to be using this one as, make sure the name is the same as here. So, and paste it. After that, let's add the rest. After adding all the parts, now we need to get the text, because like this is a path for the text, this action, not the text. So to get the text, we're just going to extract it. So I'm going to be using the with. So with open the path, so reference text path. Then we just open it in a read mode and use the encoding as UTF-8. So as F, this is gonna read the reference text file and return as a text from there. Okay, now it's time to make the GPT class. So we're gonna be using a class to load the models into a GPU during the execution, and we are gonna be using that same class for making the audio clones. So make a class, so GPT SoVITS TTS, and make a constructor. So def __ init __ and take the variables. So GPT model, SoVIT model, reference audio, and reference text. Also take the language. So in case language, mostly case it's going to be English. Take the any language that is available for the GPT SoVIT. So in this case, I'm going to take English as the default language. After that, let's make the class variables. So we're going to be needing the 3 things: self.reference audio first, reference audio, self.reference text. After assigning those, it's time to load the models. So I'm just going to be adding a text so that it shows the models are loading, because like for the first instance, the models take a little bit of time to load. So loading models, and then just call the change GPT weights function to load the GPT model first. So first GPT model. After that, just call the SoVIT model, so, and add the SoVIT model. After this is done, models are ready. Let's give a message. After that, our constructor function is done, and now we're going to be moving to the generate function and for creating the audios. So after that, make a generate function. So this generate function is going to take the text we are going to provide at the inference text we are going to be generating. The output part, the where is going to store the name of the file. So in this case, I'm going to name it sample.wave, and the speed is optional. You can give or not give, because like by default the speed is 1x. You can change it to like 0.5. We can just prompt the user to get a speech rate. So after that, make a result variable, and here call the get TTS wave function, and here pass these parts. So reference wave part is going to be a reference audio. The prompt language is going to be the language we are using. In case this case is English, so this is a reference text language, and the prompt text is the reference text, and this is the user text. The text is going to be the users which is going to prompt, and this is the inference text, the user's language, and the speed is going to be the speed. So after that, we are getting the sample rate and the audio data, and we are getting the last results, because the sample rate and audio data are the last results of this like result. So you just use -1 to get a last result and unpack it in SR and waveform. And then we are using the sound file as we imported as .sf. So sf.write, we are writing into this output part with the audio data, and this is our sample rate. After that, we are just printing a generate successful message to let the user know. So after that, let's move to the next part. So let's continue. So f __ name is equal to __ main __. So this part is only going to execute if the user directly run this program. So you can just call this from any different script, or make it into a module for generating the audio. So __ main. So we're just gonna initialize the class. So TTS GPT SoVITS TTS, then pass the parameters that it requires. So which is gonna be GPT model, SoVIT model, reference models, and reference text. So just pass this like this. GPT model is gonna be GPT model, and same like pass the rest. So after making the TTS object, let's work on a user's input. So I'm gonna be using an infinite while loop to take the text from the users and generate new audios. So user input input. So while user input dot lower is not equal to, until they provide this text exit, we are gonna keep asking them for new text. So this, and take the user input. Also add this thing, so strip. So strip is just gonna remove the beginning and trailing white space. So this is just a best practice. Let's also take the speed. So speed is a floating point value, so let's use a float for typecasting it into. So after that, if they inputted anything, if user input, then we're gonna generate. So using TTS.generate function, and just check what the parameters need. So it needs a text and a speed. So let's just pass those. So with that, we have finally completed the program, and it's time to check. So let's run it. So okay, so after this thing comes high, so just wait for a few minutes to get the models get loaded. You will see like a all keys match text come. That if that text comes, it means you have done all the things correctly, and you can now generate audio.
A few moments later.
After some time, you will see this all keys match successfully, which means all the models are already loaded. So after that, okay, now it's asking us to give an input. So let me give enter, and for the speed, let's make it 0.95, and the processing should begin. After the first generation, the rest of the generation should be much faster. So let's check. It generated a sample.wave.
Hello, how are you doing?
Okay, that was good. Okay, let's try with a different text. I can get the text from like the voice lines from here. So March 7's voice lines. Let's try to mimic one of the original voice lines. So like this one. I'm just gonna copy it. Let's try it with a brand new. You don't need to actually delete it. It is just gonna like overwriting the old file. Oh, I didn't even copy that. Just add the text and enter. And the speed, I'm gonna do 1x. The processing should begin. See, it was much faster than the previous one. So let's check.
I'm gonna get some rest after I've sorted these photos. Don't stay up all night playing video games again.
Okay, actually it was pretty good. Obviously it's not gonna be the same, but let's see.
I'm gonna get some rest after I've sorted these photos. Don't stay up all...
Yeah, original is like a little bit better. Let's try with a different voice line then. Enter, just add a speed. So 1x, the processing should begin. Oh, it was fast, so let's check. This is sometimes in VS Code, this is an error. You can like not see like the audio generated.
I came up with my name myself, but some people just call me March.
Yeah.
Which do you prefer?
It's good. So that's it. You've successfully made yourself a professional TTS engine. You can use this in many projects you're making, like a Discord bot or any AI agent you're making. And in the next video, I'm going to show you how you can make a local AI voice assistant with GPT SoVITS in the next video. And that's it. Thanks for watching, and I will see you in the next video. Bye.